My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 479. In this lecture, we will try to understand determining the right k. In k means k is the hyperparameter. Now the big question here is, how do you determine the right k? Obviously, the first step is from domain knowledge. Of course, if you know that k has to be 2 or 3, in the case of Amazon reviews, in the case of food reviews, if we know that there are only two types of reviews, positive and negative, then you could say that I want to cluster it with k equal to 2. So, in some cases, you know that from domain knowledge that there are exactly 2 clusters or 3 clusters or 4 clusters. In such a case, using the domain knowledge is appropriate way. But if you don't know what is the right k, if you want to find what is the right k, maybe because you don't know exactly whether k has to be 2 or 3 or 4, etc. Then we use very simple technique called elbow method. We know this technique, just a new name in some cases being called as knee method. Very simple idea. By the way, we have used this method previously. I am using a term called elbow method in this lecture, but otherwise it's a technique that we all learned. What is the objective function or loss function of k? Means we are trying to minimize summation I equal to 1 to k, summation x belongs to xi, x belongs to si, norm of x minus ci whole square. This is your loss across your k clusters. This is what you are trying to minimize in your objective function of k. Means what we are trying to minimize. So what we can plot here on y-axis, you plot the loss or objective function. Objective function is your objective function or loss on y-axis. You plot your loss on y-axis. On x-axis, I tried various values of k, isn't it? Objective or loss on the y-axis. Just check it out. This one, objective or loss on y-axis. There is a loss in the k means, as we discussed. This lecture is basically determining the best k in k means. On the x-axis, you have the values of k. Here on x-axis, you have the values of k. Initially, as k increases, just see, initially as k increases, the loss reduces. Just see, the loss as k increases, the loss reduces. Let's assume k equal to n. Let's assume k equal to n, isn't it? Or total number of points. Means n means what? Total number of points. N is total number of points. K is number of clusters. Isn't it? Suppose let's assume I have 1000 points. Let me assume I have 1000 points. If k equal to 1000, what does it means? It means I have 1000 clusters. How many clusters I have? I have 1000 clusters, isn't it? What does it implies? It implies that every point is a cluster. Every point is a cluster, isn't it? Every point is a cluster when k equal to n. And let's assume n equal to 1000 points, which means 1000 clusters, which means every point is a cluster. When something like this happens, what happens to your loss? If every point is a cluster onto itself, if every point, just let me erase this one, yes, if every point is a cluster onto itself, the distance of point from cluster centroid is 0. When you sum them up, the total loss should be 0. When k equal to n, loss assume this when k equal to n, this loss, your loss becomes 0. Loss becomes 0, isn't it? Which means this plot as k increases, your loss will decrease. Where k equal to n, your loss becomes 0. Why? Because just see this distance. Every point is a cluster, isn't it? This distance. If every point is a cluster onto itself, the distance of the point from the centroid is 0. Why? Because every point itself is a cluster. Therefore, your distance, the distance becomes 0. If every point is a cluster onto itself, the distance of the point from the cluster centroid is 0. That's why when k equal to n, your loss becomes 0. Plot looks like this as k increases. As plot looks like this, as k increases, your loss will decrease. Just observe this one. As k increases, your loss will decrease. Eventually, the reduction in loss will reduce dramatically. You have loss here and k here, your loss on y-axis and your k is on x-axis. This plot roughly looks like this. Let's assume k equal to 1, 2, 3, 4, 5, 6, 7, 8, so on. How will you apply elbow method? Look at this. It is sharply, just this. It is sharply falling, this area. In this area, it is sharply falling, isn't it? The sharply falling, this loss is sharply falling as we go from k equal to 1 to 5. This loss is sharply falling as we go from k equal to 1 to 5. Is it just it is sharply falling from k equal to 1 to 5. This observation is very important. But after 5, as you go from 5 to 6, just see, as you go from 5 to 6, 6 to 7, 7 to 8, etc., the reduction in loss is not significant. You can consider k equal to 5 as an elbow point. This k equal to 5, you can consider it as elbow point. Just see, forget about this. Just see, this is elbow point for hand. This is elbow, isn't it? This is for, you can consider this point. This point is very important. You can consider k equal to 5 as an elbow point. Look at this curve. It is falling very sharply and then the decrease has slowed down, slowly go to 0 at k equal to n. But if you look at the rate of change, or if you look at the steepness of descent, it is fallen very sharply. It is fallen very sharply in this region, isn't it? In this region, it is falling very sharply. Human elbow looks like this, isn't it? If you are stretching your arm and if your arm is like this, this is your elbow point. This is your elbow point. If you are folded like this, if you are doing like this, whether you have this point or this point in the this is the elbow point. This point is elbow point. This is just, if you observe both if you observe here, I can say where the curvature or the rate of change suddenly changes here, isn't it? A sudden change in the direction itself. You can take this as elbow point. Which point can be treated as elbow point? This point. This point is elbow point. So in the case of k, means your plot need not your plot, just if you observe your plot, after observing that plot, just try to identify a point where there is a sudden change. You could declare this best, you would declare the best k is you would declare the best k is k equal 5. And how do you determine that? We determined it by plotting loss on the y-axis for various values of k. This is very, very similar to what we did with the cross validation. It is similar to cross validation data to find hyperparameter. We change the hyperparameter. On x-axis. On y-axis we had cross validation loss. If you recall, here there is no cross validation. You don't have train and test data. You just, here what you have, you just have d equal to xi. You don't have class labels anyway. So what you do here is, on your total data, you basically cluster using various values of k, and whichever value results in the lowest value of loss function, or the loss defined, we already defined loss, you can take it. In this case, I just say k equal 5. This is often referred to as elbow method or knee method, because this looks like a human elbow or knee. Just go through this lecture. If you have any difficulty, just make a comment so that we will try to understand. Just go through. This formula is important. Summation of I equal to 1 to k, summation x belongs to Si. This is the formula which gives loss function, which you are taking on y-axis. On x-axis we are taking different values of k. Thank you very much.